Welcome. Like I mentioned today, hopefully we can finish 1.4 through 1.7. So 1.4, we begin 1.4 with the exponent. The two main things that we will go over is basically exponent and order of operation. Okay, the equation and translation of the algebraic expression, we will do that more in chapter 2. But the exponent, many of you guys know the exponent is in this form. The notation of the exponent is something in terms of the base, which is the big number here, the base, and the small number will be your exponent. Sometimes you will hear me say power. Power and exponent is the same, which is again the base raised to the power, or the 3 to the 4 exponent, or 3 to the 4 power is the same. So what does the exponent do? Well, the exponent is basically tell you to write the base that many times, right? Whatever the base is, they will ask you to expand them out, and to expand them out is basically whatever your base, you write that many times. So again, my base is 3, the exponent is 4, is basically tell you to write 3 times 3 times 3 times 3 4 times, which is, we know that 3 times 3 is 9, 9 times 3 will give me 27, and 27 times 3 to give me 81. So again, if you don't see that, you can see that this is what we have here. The other way to look at this is, if you look at, your calculator can help you with that. But if you look at this thing here, do you agree that 3 times 3 is 9 and 3 times 3 is 9? So again, 9 times 9, that will give you 81. So no matter how you look at it, the two questions they will ask you is to expand them out and to simplify them. So again, the expansion is basically write the product, which is 3 times 3 times 3, 4 times. And the simplification or the evaluation will be 3 times 3 times 3, which is 81. Okay, so the example 1 is basically the same idea, which is they ask you, what if we have 4 raised to the 5th power, right? 4, the base is 4, the exponent 5. So if you expand this thing out, which is now probably your calculator will come in hand. And reminder, you are allowed to use the TI-30 XII calculator, or any scientific calculator that is not graphing. They don't allow any graphing calculator. So if you do this thing here, which is again, if you expand them out, which is you say 4 times 4 times 4 times 4 times 4, 5 times. Ladies and gentlemen, it's not 5 times 4 or 4 times 5. Okay, it's 4 times 4 times itself that many times. So again, we have this, which is 4 times 4 is 16. 16 times 4 will give me 64. So on and so forth. You should get 1024. Okay, and again, same thing go. If they give you this thing here, which is 2 over 5, which is a fraction raised to the 3rd power, doesn't matter what the base is. Doesn't matter what the base is. If they ask you to expand them out, is basically you take the base, which is 2/5 times 2/5 times 2/5 3 times, right? And again, we know how to multiply yesterday. Multiply fraction is basically the top times the top times the top, the bottom times the bottom times the bottom, which is 2 times 2 is 4, times 2 will give me 8, 5 times 5 will give me 25, times another 5 to give me 125. So again, don't get discouraged if they give you a fraction raised to the power. Just knowing that whatever the power is, we write the base that many times. If the power is 10, whatever your base is, you just say that number times that same number times the same number 10 times. Okay. And again, even though if they give you a decimal, again, no fear, right? Even if they give you a decimal, 3.1 raised to the 2nd power is basically tell you that write the 3.1 times the 3.1, which is again, your calculator can do the work, which is 9.61. And again, this is the unique thing is 120, 132 raised to the 1st power, 132 raised to the 1st power. Reminder that anything raised to the 1st power just equal to itself. Okay, when we get to chapter 5, you will see that anything raised to the 0 power will be equal to 1. Okay, we will get there. But now anything raised to the 1 power, basically the 1 power tell you to write the base 1 time, which is itself. So question here with the exponent, how to expand them out or how to simplify them. And again, your calculator, you can tell your calculator, which is the caret sign. If you have the caret sign, you can tell your calculator to calculate this for you. It's just that I think on MyMathLab, some of the questions, they don't ask you to simplify, but they ask you to expand them out. So if they ask you to expand them, you just expand them out, not give them the answer, okay? So if you don't have question with the exponent, let's take a look at the order operation. And many of you guys remember, please excuse my dear Aunt Sally, right? Or whatever the anonym that you guys using, right? Again, reminder that the order operation is we using or we working with the parenthesis first. If there's a parenthesis, we work with the parenthesis first. And after the parenthesis, we would do the exponent, right? So again, if they don't have any parentheses, we ask ourselves, is there any exponent? If there's an exponent, we simplify the exponent first. And if there's no exponent, we move to multiplication and division, right? Either multiplication or division, they are equally. Ladies and gentlemen, you do not perform multiplication before division. Multiplication or division, whichever comes first from left to right. And lastly, if there's no multiplication or division, we go into addition or subtraction. Okay, so again, please excuse my dear Aunt Sally. That's what you guys mostly remember by, right? Parenthesis, exponent, multiplication, division, addition, and subtraction, right? So let's take a look at this thing here, which is, again, let's say if I give you this group of problems, right? We have 5 problems here, and as you can see, slowly from A, B, C, D, slowly is increased the difficulty, right? So if you look at A, we can see that we have addition, exponent, subtraction. There's no parenthesis. So we know, looking at our order operation, we know that we need to perform the exponent first and then work from left to right, right? This thing here, we have exponent, division, multiplication, reminder. We do the exponent and then work from left to right, okay? So let's take a look at this thing here. And again, we would do one problem at a time. So the next screen, if you did not copy this, everything down, don't worry. We would do each problem. So let's take a look at A, right? So this is your A problem. This is 4 plus 5 squared minus 16. So we know if you remember the OR operation, looking at this thing, like I mentioned earlier, we have to do our exponent first. Right. So if there's an exponent, addition, subtraction, we need to do the exponent, and the exponent tell us that the 5 times the 5, right? Write the base that many times, which is 5 times 5. We know that 5 times 5 is 25. And ladies and gentlemen, looking at this thing here, we just work from left to right, which is looking at this thing here, we know that 4 plus 25 to give us 29. And again, hopefully from now, it's just a smooth sailing, which is 29 minus 16 will give you 13, right? So again, one thing is I know that looking at the original problem is look massive, right? If you look at this original problem here, you say, wow, this original problem massive, but take one step at a time, right? Ask yourself, what do we do first? What do we do in the sense of, again, if there's exponent, we do that, right? It's just make like a checklist, right? Parenthesis, exponent, multiplication or division, addition or subtraction. So let's take a look at 2, and then I will pause and ask you guys have question because, so looking at this thing here, same thing go, right? If you look at this thing here, we know that we have exponent, right? If you look at this item, we know that we have exponent, we have division, we have multiplication. So we know that exponent comes first. And again, I purposely give you this problem to make sure that you have to work from left to right. A lot of students have that habit. They say multiplication before division. Multiplication and division is equally, okay? You have to work from left to right. So looking at this thing here, if you attack this, we know that the first thing is we need to evaluate this exponent. And we did this already, right? We did this already, which is again 3 raised to the 4 power, which is 3 times 3 times 3 times 3, which is again is what we did earlier, which is 3 times 3 times 3 times 3 will give us 81. And ladies and gentlemen, reminder, this is the very, I know you guys can multiply. I know 9 times 2 is 18. You guys can do that, but please do not do that because that will give you a wrong answer. You have to work this from left to right, which is in this case, we need to do 81 divided by 9 first, which is 81 divided by 9 to give you 9, and 9 times 2 to give you 18. Please, please, please do not do 81. Do not do 81 divided by 18 because you have to work from left to right. Okay. So again, first of all, before I go on, before I continue, let me ask you guys any question with A or B here. Any question with A or B? So if you look at C, you say, wow, C is a little bit, a little bit different than A and B because now we have a numerator and the denominator, right? So one thing is, again, we have 9 plus 27 divided by 9, 8 minus 5, right? So one thing is reminder or looking at this thing here, if you go back to this item, and like I mentioned, I will post this slide tonight on Canvas. So if you did not able to copy everything down, you will have a copy of this slide on Canvas by tonight. So one thing is they say that if you have a fraction, all you need to do is simplify the numerator by itself, simplify the denominator by itself, and then you simplify the whole problem. Okay, so we treat the numerator as one problem, we treat the denominator as one problem separately. Okay, so looking at this thing here, let's attack the numerator, right? The numerator, if you look at this thing here, the numerator, we have addition and division. We know that division is ahead of addition, which is we need to divide first. So if you divide, again, 27 divided by 9, or 9 go into 27 will give me 3, which give me now, looking at this thing here, I know that on the numerator, 9 plus 3 to give me 12, and the denominator, 8 minus 5 to give me 3. So again, looking at this thing here, we treat the numerator as one problem, we treat the denominator as one separate problem, and now we treat the whole thing, which is, again, hopefully now it's just a smooth sailing, right? Which is 12 divided by 3 to give you 4. So again, question with this one problem here, which is, again, I know if you look at C by itself, right? If you look at C by itself, you say, oh, where to start? Just ask yourself, just block it. If you in doubt, just block the denominator, right?
So you do division and multiplication before addition and subtraction.
Yes.
Okay, so that's where you got the 27 divided by 9 is 3, so 9 plus 3 is 12.
Right.
Okay, gotcha.
Right. Again, like I say, if it's the problem too massive, like I say, block the denominator, right? Just block the denominator first, right? If it's too massive, just work with the numerator. Everybody agree that if I work with the numerator between addition and division, I know that, again, my rule is division before addition, right? So I need to divide first, which is 27 divided by 9, give me 3, and 3 plus 9 to give me 12. So once you finish with the numerator, now you block the numerator and then do the denominator, which is the denominator is not that difficult, right? It's only 8 minus 5, okay? So question with this one here, question with C. And then you say, ooh, let's go back to C. I don't want to do D. Just kidding. I know if you look at this thing here, it's massive, right? You see this thing here. And just like before, if it's too massive, just block the denominator for now, right? You look at this thing here, just look at this item here. So a little bit variety, I want to give you the variety in terms of this thing here. You have the absolute value, which is you say, wait a minute, what is the deal with absolute value? Remember yesterday, absolute value is anything in absolute value when you extract them out is positive, right? So you say, well, Mr. Tran, on the order operation, you don't have any absolute value. Well, one thing is absolute value is like a parenthesis, okay? It's like a grouping. It's just the only thing different between the absolute value and the parenthesis is when you extract, when you want to get rid of the absolute value, the number that come out will be positive, okay? That's the only thing different. So if you look at D, we know that we need to do any grouping item first, which is 32 minus 8. That's what the first thing we need to do, which is that is the grouping instead of parenthesis is the absolute value. So looking at this thing here, to go back to this item, this is what we want to do is we want to do any grouping, which is again, we want to get rid of the absolute value. So the first thing I have is I need to take 32 minus 8. Which that should be an easy number, which 32 minus 8 will give me 24. And again, I want to get rid of the absolute value. Anything come out of the absolute value is positive, which is again 24. You can just get rid of the absolute value, which is again, because positive 24 is the same, right? The only thing different is if it's negative 24 inside the absolute value, when you take it out, then it's become a positive. But again, everybody see that after the first two steps, this problem similar to C, right? Is go back to C, right? So looking at this thing here, same idea with D to C, the first thing I want to do is, again, I want to work with 24 divided by 4, right? Because I know that numerator division over addition, right? So again, 24 divided by 4, I have 6. And again, let me do on the denominator, which is, do you agree that 5 to the third power. 5 to the third power, which is 5 times 5 times 5, which is 5 times 5 is 25. 25 times 5 will give me 125. So everybody see where I have the 6 and the 125 came from. And like I mentioned previously, they tell you that you treat the numerator by itself like one problem and the denominator like one problem. So again, a lot of you guys probably don't do all this step. You guys probably do some multiple step in one. I just break this down to show you that what step I took, okay? So again, once you have this thing here, 3 plus 6 will give me 9. And 125 divided by 25 to give me 5, which is that will be my answer, right? So question with D, question on which step, if I lose any of you in any of the step here in D. So I take it you got D. So look at E, and again, you probably say, ooh, this is massive, right? We have addition on the outside, bracket, subtraction, parenthesis, exponent. So basically everything except multiplication and division. Well, we have multiplication. It's hidden. Multiplication is right here. So one thing, ladies and gentlemen, please, please, please. I know addition is easy. I know a lot of you guys like to do this, but please do not do it. Okay, please do not add 4 plus 2 first. The reason why I say this because every semester when I give out a test, I have 2 or 3 students, they jump in and they add 4 plus 2. I know 4 plus 2 is 6, it's easy to do, but that is not the right steps, okay? The first thing you need to do is you need to simplify your bracket, okay? So once you simplify your bracket, then you do that. So looking at this thing here is like a camera, right? We need to do a bracket, but inside a bracket, we don't know what 18 minus what this number is. So the first thing we need to do is we need to do this parenthesis. So if we do the inside the parenthesis, which is again, that's the first thing I want to do is I want to get rid of that parenthesis, which is the get rid of parenthesis is easy, which is 7 minus 3. All of you know 7 minus 3 is 4. Right? Which is again, looking at this thing here, I need to get rid of this bracket. But before I get rid of this bracket, I need to know what this exponent is, which is everybody see that the next step I need to do is I need to get this exponent, which is this exponent, which is 4 raised to the second power, which is 4 times 4, which is 4 times 4 to give you 16. Now, everybody see that we need to get rid of this bracket. Or we need to simplify this item, which is, again, if I simplify this item, all of you got this, which is 18 minus 16 is 2. And now everybody see that this thing here is the implication of multiplication. 2 bracket 2, meaning 2 times 2. So we need to do this item first because it's a multiplication. So again, this is the item we need to do because again, there's an implementation that this is your multiplication, which is if you multiply this together, you will get 2 times 2 will give you 4, which is again 4 plus 4 will give you 8, right? So again, looking at this thing here, that is your answer in the center of that, which is again, I know if you look at the original problem, right? If I give you this original problem here, each of this problem look massive, right? Each of them look their own unique weight. But again, no matter how massive the problem is, ladies and gentlemen, just ask yourself, what can I do first? Follow your rule. Bracket, parenthesis, absolute value. That's the first thing you need to do first, right? Exponent, multiplication or division, and then addition or subtraction is the last thing you need to do, okay? So first of all, question with this OR operation here, question of how I have each of this problem. Any question in where my answer come from? All right.
All right. So
Yes.
hi, I'm sorry. I was having problems with this computer or whatever. Go over E kind of quick once again. I've written everything down, but just run over it real quick with the rules real quick.
So again, same thing go, right? Looking at this thing here, we know that we need to get rid of your parentheses first. So inside your parentheses, which is 7 minus 3 will give you 4, right? Which is again, once you have the 4, we have to get rid of the exponent, right? Because again, it's parenthesis, exponent, multiplication, division, then subtraction or addition. So you never ever want to add first. You never ever want to subtract first, right? Those are the last thing we want to do, right? So again, 4 times 4 to give you 16. And once you have 16, now we need to get rid of this. I know you say, well, why do we not multiply? It's because this 2 number is in the bracket. So we want to get rid of that bracket. And to get rid of that bracket, we have to subtract inside the bracket first, right? Which is again, if you subtract to give you that. If you multiply, later on you will see that if you multiply, you have to take the 2 times the 18 and the 2 times the 16. But again, for now, just simplify inside your bracket, which is once we simplify in the bracket, now we have to take the 2 times the 2 to give you 4. And the last step is 4 plus 4 to give you 8.
Okay, thank you.
All right. So any other question here with the OR operation? And again, later tonight, try to see if you can work on the OR operation on your homework. There are a few questions on your homework. And again, whichever question that you stumble on or stuck, either send me an email or bring it to the class tomorrow. And first thing tomorrow, we will do those questions that you have. If you send me an email, I can type it up and then we can start with those questions if needed, okay? So if you don't have question with OR operation, now let's take a look at the expression, how to evaluate the expression. So this is what we will have, or in the sense that they will ask you to evaluate each expression. And again, the only thing you will see that the difference between the expression versus the equation is the equation, they have an equal sign. The expression do not have a equal sign. So basically they ask you to evaluate this thing here, 7x minus 2y. So in order for you to evaluate, all you need to do is, again, they just tell you that all you need to do is replace the number into your variable, right? Whatever that number that you have. And the careless mistake a lot of students do is they place the wrong number for the wrong variable. So all you need to do is wherever you see your x, you plug in the 3. Wherever you see your y, you plug in the 2. So basically you just need to substitute plug them in, right? Which is, again, looking at this thing here, everything else should be easy now, which is 7 times 3. Instead of 7 times x is 7 times 3, 21. 2 times 2 is 4. And again, hopefully now is a smooth sailing, which is 21 minus 4 is 17. So again, all you need to do is, in order for you to evaluate, all you need to do is take a look at your variable and plug in the corresponding number, right? So one thing, be very careful, ladies and gentlemen, be very careful with B. Let me ask you this question. Does the exponent 3, does this exponent associate with the 6?
Yeah.
No.
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 Hopefully you guys see that it's no, because the exponent 3 is only associated with the y, meaning it's only the y that get raised to the third power. It's not the 6 raised to the third power. It's just the y, which is, again, my y is 2. So in this case, 2 times 2 times 2 is only the 2 that raised to the third power. So if you look at this thing here, if you multiply them out, 6 times 2 to give you 12, 12 times 2 to give you 24, and 24 times 2 to give you 48. Okay, so again, make sure, and again, this is the difference between B versus C. This is the difference between B versus C, which is, again, as you can see, in C, there's a parenthesis. Meaning if there's a parenthesis, now the 3 and the x are associated with the square or with the power of 2, right? So if you do this thing here, which is, again, my x is 3, my 3 is the original number, which is, again, I need to do inside the parenthesis first, which is 3 times 3 is 9, and then 9 times 9 is 81. So again, hopefully you guys see, you guys can distinct if there is no parenthesis. If there's no parenthesis, the constant does not associate with the power. If there is a parenthesis, then the constant is associated with the power. Okay, so make sure that you have this thing here, the difference between B and C. Okay, and again, let's take a look at one more, which is, again, well, two more. So again, no matter what they give you, right? If they ask you to evaluate this thing here, which is, do you agree that if they ask you to evaluate this item, all you need to do is plug in the corresponding letter to the corresponding number, which is my y. Wherever I see a y, I plug in the 2. Wherever I see an x, I plug in the 3, which is now, do you agree that 7 times 2 is 14? 3 times 5 is 15. Which is, that's all we have. There's nothing to simplify. If you want to give me decimal, you could, but again, the fraction should be fine, right? And lastly, if they give you something like this, which is, again, don't freak out, right? If they ask you to evaluate, all you need to do, plug it in, which is, do you agree that 9 over y is become 9 over 2? X over y become 3 over 2. And life is good. Why? The denominator is the same. And reminder from yesterday, if the denominator is the same, all you need to do is combine the top, kept the bottom. Right? Or in this case, 9 minus 3, subtract the top, kept the bottom, which is 9 minus 3 is 6. 6 divided by 2 to give me 3. So again, evaluation or evaluate this expression is easy because, again, if you in class, I keep on telling my students, be clay, right? Be clay, plug it in, right? Plug it in the right number for the right letter. But those commercials are no longer on TV. But anyway, question here with evaluation here.
So is y always 2 and x is always 3?
For this problem, yes.
Okay.
For this particular problem, yes. Because I'm kind of lazy, I just give that. On your homework, they might change depending on the problem. Like let's say the y can be 2 and the x is 3, and then the next problem they give you the y is equal to 7 and the x equal to 19 or something like that. So it depends on your homework. For this one here, for all this thing here, I use the same x and y. Okay.
Okay, thank you.
So they will tell you what x and y, or sometimes x, y, and z, what do they represent. You just need to see what they give you and plug it in.
I have a question.
Yes.
Are there some problems where there's not a representation for the x and the y? Like, for example, you have to figure out what x and y is.
We would do that in chapter 2.
Okay, all right.
We will do that in chapter 2. For now, whatever they ask you to evaluate, they will give you. If the variable is A and B, they will give you what is A represent and what B represent.
So they'll tell you what the number is.
Exactly.
Okay,
Exactly.
I got you. Thank you.
All right. So not the last thing. The second to last thing that we have is solution for the equation. And like I mentioned to you guys, the only thing different between the expression like we have earlier and the difference between expression that we have earlier and the equation is, in the equation they have a equal sign. Okay, if there's an equal sign, which is in chapter 2, when there's an equal sign, they will ask you to solve for something. And for now, we will not solve yet. What we will do is we will ask you to verify if the number I give you is the solution, right? So how do we know if the number that we give you is a solution for equation, meaning something like this? Determine whether -8 is a solution for this equation here. So basically, everybody see that they give you this equation. They give you this equation here, which is, this is your equation, 23 plus x equal to -17. Now they want you to verify, to tell them, is this number, -8, a solution of this thing here? So how do we do this? Just like we just do previously, it's just that they write it different, right? All you need to do is the same as before, which is you plug it in. So wherever you see x, wherever you see that variable, you just plug in the number they give you. And what your goal is you want to see if the left-hand side is equal to the right-hand side, which is, again, do you agree that 23 plus -8 or is the same as 23 minus 8? Which is, again, 23 plus a negative, which is the same, 23 minus 8 to give you 15. Clearly, you can see that 15 is not equal to -17. And if it's not equal to, you would say, no, -8 is not a solution for this equation, okay? So that's how you verify. Your goal to verify if they are a solution, all you need to do is ask yourself, is the left-hand side item is equal to the right-hand side item by plugging in whatever they give you. So in this case, do you see that all we need to do is plug in wherever I see my x, or wherever the variable that they give me, I plug in the number that they ask, which is, in this case, do you see that, again, my x now changed it to number 7, which is 2 times 7 plus 3. So what is 2 times 7? Hopefully you guys say 14. 14 plus 3 to give me 17, which is, do you see that 17 is equal to 17? So therefore 17 equals 17, we know that yes, we say that because they are equal, yes, number 7 is a solution for this particular equation, okay? And that's all they ask you to do is, can you verify, right? Basically they ask you is, can you verify that this item here, whatever this item is equal to this item? So if you simplify them out, which is, you can see that 17 and equal to 17, which is, again, this will give us a check, right? This give us a check. And if they give us a check, which is, again, too light, but again, it is a check, so we know that they are a solution. So again, question with how to determine if a number is a solution for your equation here, which is the same idea as your previous one, which is, again, just basically plug it in and simplify. You are not solving, ladies and gentlemen, you are not solving, so you are not moving anything across the equal sign. All they ask you to do is plug it in and simplify whatever side you plug it in, simplify that side to see if it's equal to the other side, okay? So question with this one here. All right, if you don't have question, let's continue with the last item we have, which is, again, this is in 1.5 and 1. Well, don't worry for this one yet. I just give this thing up here just because we will use this. We will go back to this thing here in chapter 2. Basically, this thing here just to tell you that the different word, the different English word represent the operation you have, right? If you see the word sum, if you see the word plus, if you see the word added, more than, increase it by, or total will give you the addition, right? So again, this is just a list of the English language that correspond to the math operation. We will go back to this chart later when we get to chapter 2. So for now, I just give here so that you guys have a copy of it. We will go back in detail of this thing here. So for now, don't worry about this chart, okay? So let's take a look at 1.5 and 1.7, 1.5, 1.6, and 1.7. So 1.5 all the way to 1.7 is basically tell you that now, whatever you just learned, your order operation, whatever you just learned before, now we will do that with a real number. And again, for me, a rule of adding real number. I know some of you guys learn a little bit different. And again, if you know how to do it, it's fine. For me, this is what I tell my students, make it easy to remember, is when you add or subtract real number. Remember, real number is negative number and positive number, right? The real number line, your negative number, 0 and positive number, right? So for me, is when you add or combine a real number is for any two number or a pair of number, right? For any two number or pair of number, if they have the same sign, all you need to do is you add and keep the sign. If for any two number, if they have the same sign, you add and keep the sign. For any two number, if they have a different sign, then you subtract and keep the sign of the larger number, okay? The larger number, I know sometimes it's not the value that I'm looking for. I'm looking for the actual larger number. So if you look at this thing here, this is basically, this is what I asked you is for A, right? For A, we have a negative 13 plus a negative 21. So you ask yourself, this is my two number, negative 13 and negative 21. Do they have a same sign or do they have opposite sign, right? Do they have the same sign or different sign? So if you look at this thing here, we have a negative 13 and a negative 21, which is they have a same sign. So for me, if they have the same sign, all you need to do is add and keep the sign, which is 13 plus 21 to give you 34, which, my typo, sorry. It should be 34, not 44. Let me edit. 34. I was so happy that I almost done with the slide, so I have that. So it's 34. So again, 13 plus 21 is 34, which is again, because they have the same sign, we kept that sign, which is negative 34, okay? So again, some student, if you put it in the money's perspective, a lot of students like to put this in the money perspective. If it's negative, meaning you own somebody something. If it's positive, meaning you have the money. So again, you own me $13 and then you own me another $21. In total, you owe me $34, right? So again, that's what I have in the sense that if they have, for any two number, if they have the same sign, all you need to do is add and keep the sign. If they have a different sign, which is in this case, we have a positive 5 and a negative 37. So all I'm telling you is if they have opposite sign or different sign, all you need to do is subtract and keep the sign of the larger number. So I know the value. Again, for me, this is the larger number between 5 and 37. 37 is larger. I agree with you guys that negative 37 is not bigger than 5. The value, negative 37 is not bigger than 5. Yes, I agree with you 100%. But when I say keep the sign of a larger number, meaning the actual number itself, okay? So in this case, all you need to do is, again, for me, because they have opposite side, I subtract, which is 37 minus 5 to give me 32, and kept the side of the larger number, which is the larger number is negative 37. So the side would be negative, right? You owe me $37, you pay me back $5, you still owe me 32, right? So again, if you put that in the money perspective, that's what you do in that sense. And again, looking at this thing here, if you see this item here, you just go like before, right? This is the OR operation, is just that now we have a simple side. But again, looking at this thing here, it doesn't matter how big the problem is. Just look at two number, right? Any two number at a time. So clearly, you all know how 19 minus 4, right? Clearly, you know 19 minus 4 to give you 15. And then 15 minus 12, again, looking at this thing here, there's no unique, right? But if you say, well, why do I not using the root I use here? Well, 19 is positive, 4 is negative. They have different sign. I subtract and keep the sign of a larger number. So again, it's the same. But you don't need to use that rule because a bigger number minus a smaller number, you know what to do, right? So again, looking at this thing here, just like before, right? We treat two number at the time, which is 2 take away 51. So a smaller number take away a bigger number, somebody will get a black eye, right? A smaller number get a bigger number. Again, looking at this thing here, 2 take away 51, or when you subtract them, again, you will have a negative 49. And again, negative 49 and a positive 21, because they have different sign, we have to subtract and keep the sign of the larger number, which is in this case, we have a negative 28. Okay, so again, this is what we have, or this is what I tell my student is when you add or subtract, just ask yourself, do you have the same sign for the two number? If they are the same, we add and kept the sign of the larger, kept the sign. If they don't have the same sign, we subtract and kept the sign of the larger number. Okay, and again, your calculator, if you don't want to use the rule, then you have to know how to use your calculator. So again, make sure to know, the calculator is only as good as the user, right? You have to input the right number for the calculator to output the right result. So make sure you know how to type in your calculator, okay? So let's take a look at one more item, which is the second rule of real number is when you multiply and divide. When you multiply and divide real number is basically, again, for any two number, if they have the same sign, when you multiply or divide, if the two number have the same sign, the result will be positive. If they have different sign or opposite sign, the result will be negative. Okay, same sign, the result will be positive. Doesn't matter if both positive or both negative. If they have the same sign, the result is positive. If they have opposite sign, the result will be negative. So looking at this thing here, I have my 8 multiplied to negative 5, right? It's not 8 minus 5. If the A is inside, then it's 8 minus 5. But again, 8 multiplied to a negative 5, which is again 8 and 5. One of them is positive, one of them is negative. 8 times 5 is 40, and the result will be a negative 40. Okay, and similarly, right, negative 4 times a negative 13. A negative times a negative will give me a positive, which is again 4 times 13 will give me 52. The result will be positive 52. Okay, so again, that's the rule for any two number. If you multiply, if they have the same sign, the result will be positive. If two number, if they have opposite sign, then the result will be negative. Doesn't matter who is bigger than who. If they have a opposite sign, the result is negative. So looking at this thing here, same idea, right? No matter how many problems you have, just treat two number at the time, right? So looking at this thing here, you just take this 6 times this -2, right? Take 6 times -2, which is 6 times a -2, positive 6 times -2 to give you a -12. And then -12 times a -10, which is a negative times a negative, will give me a positive, which is, again, in this case, you will have a positive 120. And whoever say, oh, Mr. Tran, I did not do what you did. I take a -2 times a -10 to give me a positive 20, and positive 20 times 6 to give you a positive 120 is fine. Multiplication is associative, meaning, again, no matter how you multiply them, 3 times 4 times 5 is the same as 5 times 3 times 4, okay? So looking at this thing here, similarly, right, you just take a look at two numbers at a time, which is, again, for me, I work from left to right, which is -7 times -9, -7 times a -9 to give me a positive 63, right? And a positive 63 times a -2 to give me a negative 126, right? So again, two number, when you multiply two number or divide two number, if they have the same sign, the result will be positive. If when you multiply or divide two number, if they have opposite sign, the result will be negative, okay? So again, those are the rule. And if you do the homework, you will see that they throw this rule into your order operation, okay? So looking at this thing here, question with the rule. Question with the rule in terms of when the result addition and subtraction versus multiplication and division. Now, before I let you guys go, let's take a look at this two problem. Similar to this item before, does the negative associate with the two? Just similar to last time I give you like 6x raised to the third power. Looking at this problem here, reminder that the negative do not associate with the two, okay? This thing is basically the 8 times the 8. 8 times 8 to give you 64, and you kept that negative sign, okay? The negative, let me do it this way. This is basically this item here, ladies and gentlemen. This right here is this item here. So again, for this problem, is only the 8 is associated with the square, which is the 8 associated with the square, which is basically 8 times 8, and 8 times 8 is 64, and then you kept your negative, you bring your negative over, versus this item here. As you can see, E and F, the difference between E and F is the parenthesis, right? If there's no parenthesis, the negative do not associate with the square. If there is a parenthesis, which is in this case, there's a parenthesis, which is a negative times a negative, which is everybody see the difference between E versus F, okay? That is the biggest concern, or that is the biggest mistake a lot of students do, is if they don't have a parenthesis, you have to leave that negative by itself. Carry down, carry over, carry over, carry over. If there's a parenthesis, that's when you kept the negative, okay? So again, this is the end and